Welcome, good evening, friends. So now we have come to a stage where we can apply the knowledge that we gained in previous video classes regarding differentiation. So we are applying now differentiation for our practical problems. Practical problems are of many types. Some business institutions will be there where they have multiple inputs that will be deciding the ultimate profit of the organization. So we have to find out the maximum profit by minimizing the various expenditures, losses, etc. So there differentiation is used. Suppose if we have got an equation for a curve, we should be in a position to find out without actually plotting a graph what is the maximum and minimum of this equation curve, because generally curves will be sometimes look like a sine wave. So they will have a positive peak and a negative peak. Both we can find out simply by applying the differentiation. Also, we will be able to find out equation of tangents at a given point for a curve. Equation of normal we can find out at the same point. Also, we can find out the slope of a particular domain. Within the domain, wherever critical points are there, there you can find out whether the function is continuous or discontinuous. So there are various uses in practical issues. So we can use this differentiation for all these purposes, particularly in the case where suppose you are having a rectangle. In rectangle, let us say length is varying with respect to time. Then in what way the area will be varying? This type of problems will be encountering. Equally, sometimes circle is there. If the radius is increasing, suppose if you throw a stone in a steady pond, what will happen? Circles are generated. These circles will be increasing in radius having a common center. So areas will be increasing. So the rate at which areas will be increasing, the rate at which radius will be increasing, both have a application of differentiation kind of sums. So friends, today we will do a few sums now based on the applications of derivatives. Okay. Yeah, let us begin the sums of these applications of derivatives. These sums are taken from NCERT textbook. Let us go to the whiteboard. Yeah. See, I told you in this type of sums, they'll be only asking us to find out what is the variation of area if radius is changing, like that. So let us see the first sum. Given R of a circle as 3 centimeter, this is the radius. Find variation of area with respect to radius. This is the sum. So let us see how to do this very simple sum. They said that R is equal to 3 centimeter, no problem. So A is equal to, what they're asking us to find out, they're asking dA by dr is how much? This is what they're asking. Find the variation of area with respect to radius, dA by dr. So parametric differentiation, what we have done, will also come into use in certain sums of this exercise. Okay. So let us see what is the formula for area. Area is equal to pi r square, that we know. So differentiate both sides with respect to the radius, dA by dr. So pi as it is, r square differentiation is 2r. Okay. Now this is nothing but 2 pi r we got, centimeter square. At what radius they wanted? Given our circle 3 centimeter they wanted, let us say. At r is equal to 3 centimeter, dA by dr, if you want to find out, that will become 2 pi into 3. Nothing but 6 pi centimeter square. This is the variation of area with respect to the radius. Understood, no? Let us go to the second sum. Second sum is referring to the cube. Given volume of a cube is changing. It is changing. Changing how? With time. So this is also important. Changing with time as dV by dt is equal to 8 cc, means 8 centimeter cube. They have given dV by dt as 8 centimeter cube per second. Now here, what they're asking us to find out now, find the variation of surface area. Find change of surface area with respect to time. This is the sum. So what we do, first we will understand. Also, what they have given is surface area with respect to time, where A is equal to 12 centimeter, they said. At A is equal to 12 centimeter. That means the side of the cube. Generally, we represent small a. Let A be the edge or side. Both are same. Edge of the cube. Cube looks almost like this only. So this is A, this is also A, this is also A. All will be same. So what is the formula for volume? Volume of cube. Why we have to take volume? Because they said dV by dt. They have given for us. That we will be taking in our equation and then find out dA by dt. I will show you by doing this, you will understand. So volume of cube is nothing but V is equal to A cube. So dV by dt we will do. With respect to time, we differentiate. Differentiate with respect to time. A cube differentiation 3a square dA divided by dt. Now here they have given this as 8. 3 into at 12 centimeter we will find out what is the dA by dt value. So here A is equal to 12 they gave, no? So dV by dt at 12. So 8 is equal to 3 into 12 whole square dA by dt. This will become 3 into 144 into dA by dt. Correct, no? So then we can write down here. This implies 8 divided by 3 into 144 is equal to dA by dt. Now 8 will go how many times? Here 18 times. So we have got here 1 by 54 is equal to dA by dt. This you keep it as first equation. This is important now for us. What we have to find out now? Variation of the surface area. Surface area of cube is, let us say, yes, we call it as the letter 6a square. So differentiation with respect to time will give us the variation of surface area. A into dA by dt. So ds by dt we will find out now at where at A is equal to 12. We have to find out 12 into 12 dA by dt we have found out previous page 1 by 54, that we will substitute here. Okay. So if we divide this, what you will get? Let us do it. 3 4s are 12. 3 18s. 6 3s are 6 2s are 2 into 4 8. 8 by 3 centimeter square per second. This is the variation of the surface area. So whatever they are asking, we should ultimately find out from the formulae correctly by writing down them. If they are dealing with the cube's surface area, cube volume, correct formulas we should write. If they are dealing with rectangle, rectangle's perimeters, rectangle areas, circle means pi r square, all that we should remember. Okay, and apply this variation formula, simple only. Then next sum, let us see. In the next sum, what they're asking, they have given dr by dt, variation of the radius, given variation of radius. Variation of radius of circle. Of a circle, they have given dr by dt. With respect to time, they have given how much it is 3. What they're asking us to find out? They're asking us to find out the variation of area. First sum, like almost, find the variation of area when r is equal to 10. R is equal to 10 centimeter. So simple only. Let formula write on clearly, circle area pi r square. So dA by dr we will do 2 pi r into dr by dt. 2 pi r into dr by dt. Dr by dt they have given 3. So r value 10. We should substitute now 2, 10 and 3. dA by dr at r is equal to 10 is given by 2 into pi into 10 into dr by dt they have given us 3. So multiply 60 pi. This is the answer. Okay. Let us go to the next sum. What is our next sum now? They have given this time. Yeah. For a cube. For a cube, they have given a variation of the surface area. For a cube, given variation of surface area. That is dA by dt they have given. This A will write better capital now, so that it will become easy for us. How much it is? Yeah, it is given variation of the side, I think. Yeah, not the, for a cube given variation of the side. So here it's not the surface area, it is a side. Yeah, that they have given 3 centimeter per second. So this is again small a only we should write here, so that, yeah, 3 centimeter per second. What we should find out? We have to find out dV by dt, volume variation at what? At A is equal to 10. Simple sum. So V is equal to, what is the formula for area? Sorry, formula of volume of a cube. Volume of cube is a cube. So dV by dt, let us write down clearly. It is 3a square. Differentiation of A is dA by dt. All we are having at A is equal to 10. dV by dt we have to find out now. 3 into 10 square into dA by dt value 3. We are substituting all the things. 300, 900 came. Centimeter cube per second. So all the things we have to remember what they have given, what we have to substitute. Next sum. In this case, they have given again, given variation of radius of a circle dr by dt. This they have given. What they're asking us, find the variation of area. Find dA by dt. Okay, where what is area? A is area of circle. Already we have done this, so one repetition only. A is equal to pi r square. So dA by dt will become 2 pi r to dr by dt. Okay. So here 2 into pi into r value we have not given, they have not given anything. So 2 pi r they have given 8 at r is equal to 8. Yes, r is equal to 8. So 2 pi into 8 into dr by dt is 5. So how much it will become? 2 into 8, 16 into 5, 80. Okay. So we have to know exactly at what value they are asking us to find. Sometimes they don't give r. So we can leave it 2 pi r into 5. So that means 10 pi r we can, but r we have to substitute. They give. So next sum. In this case, circle they have again circular sum this is given variation of radius of a circle dr by dt. How much they gave? 0.7 centimeter per second. What they're asking? Find variation of perimeter. Find the variation of perimeter. dP by dt. dP by dt is how much? So let us see now. Perimeter formula. Perimeter of circle P 2 pi r. So differentiate now, because they are asking dP by dt. 2 pi into dr by dt. So 2 pi dr by dt is 0.7. So 1.4 pi centimeter per second, because perimeter, so square will not be there. Okay, keep in mind. Let us go to the next sum. Here, this sum is very, very important sum. There is a rectangle. In this sum, what they are telling is, there is a rectangle whose length is determined by or denoted by x and breadth is denoted by y. What they said is, given dx by dt, that is change of length, decreasing by -5 centimeter for every minute. On the other hand, dy by dt is increasing by 4 centimeter per minute. Okay, given dx by dt is -5, dy by dt is 4. So what they're asking us to find out is, they're asking us to find out what will be the dA by dt. Find dA by dt. Okay. Yeah, dA by dt when x is equal to 8 centimeter, y is equal to 4 centimeter. They're asking us to find dA by dt at these values. Also dP by dt. Also find dp by dt at the same values. Let us solve this sum. So first, what is the perimeter of rectangle? P is equal to 2 into x plus y. So dp by dt is equal to 2 into dx by dt plus dy by dt. 2 into what is dx by dt? Here they are given minus 5. What is dy by dt? 4. So this is equal to 2 into minus 1. So minus 2 centimeter per minute. This is the variation of perimeter. What about area? Area is equal to length into breadth. Sorry. Length x into y. Here we are represented length into width. So x into y. So let us differentiate dA by dt. We should find out now. So x into dy by dt, because UV method here, y into dx by dt. So at what values of x and y they wanted? At x is equal to 8, y is equal to 4 centimeter. They wanted the dA by dt. So x value 8, dy by dt they were given 4, y is 4, here minus 5. So this is 32 minus 4, no, this is 6. Let us see once again, y value. Y is equal to 4 only we are taking, no? Yeah. So we have to substitute here 32 minus 20, that will become 12. 12 centi, 32 minus 20, 12 centimeter square per minute. This is the variation, okay, of the area. So I think I am skipped this page. I'll write here again the same sum. Don't get confused. dA by dt we have to find out. So x into dy by dt plus x into dy by dt plus y into dx by dt. So x value here 8, dy by dt is 4, y value 4, dx by dt is minus 5, 32 minus 20, that will become 12 centimeter per minute. So hope you followed this. I will give the serial number 9. I think 8 sums we have done. In this sum, they said that there is a spherical balloon. This spherical balloon, whenever you put air into the balloon, it will be inflating. It will be growing in volume. So volume of balloon they gave at the rate like dV by dt they have given. dV by dt is equal to 900 centimeter cube per second. This is the rate at which the volume is changing. What they're asking us to find out. Find the rate at which radius will change. Find dr by dt of what? Of the balloon. So balloon shape we should remember, it is a spherical shape. Okay. So therefore volume of sphere we have to take. V is equal to 4 by 3 pi r cube. So dV by dt is equal to 4 by 3 into pi into 3r square into dr by dt. So 4 by 3 into this, of course, this 3 and 3 get cancelled. This 3 and this 3 will go away. And 4 pi r square dr by dt. dv by dt, they have given you 900. They said that r is equal to 15. At r is equal to 15 centimeter. This equation will become 4 pi into 15 whole square into dr by dt. So let us find out first dr by dt from this. It is useful for us now to find out the 4 pi 225. This 15 square becomes 225 when you bring this side. So now 4 will go 225 times 225, 225 cancel. So 1 by pi remained. 1 by pi is equal to dr by dt. Over, sum is over. So dr by dt is equal to 1 by pi centimeter per second. Understood now? So what we found out now, we took the formula of volume 4 by 3 pi r cube of a sphere, differentiated with respect to time, and then substituted r value 15 centimeter. They gave this. At r is equal to 15 centimeter, find dr by dt. Here I write again, at r is equal to 15. So that is how we can do this sum. Next sum. They said that there is a ladder placed against a wall. I'm drawing the picture. In this sum, there is a ladder. AB is ladder for us. AB is ladder. AB length they have given 5 meter. A is foot of ladder. So let OA is equal to x meter. OB is equal to y meter. Given dx by dt, they have given. It is actually moved. This ladder is actually what is happening. It is pulled. So it is when this is pulled this side towards this right side, it will be reducing in height. So this point B will be coming down and down. Just I am putting for you little bit in this fashion I'm telling. Okay. Now dx by dt they have given us 2 centimeter per second. What they're asking now, find dy by dt. Find dy by dt when x is equal to 4 centimeter total length. Ladder length is 5. So what we have to do now here, use the Pythagoras theorem. From triangle OAB, x square plus y square is equal to 25. So differentiate now. 2x dx by dt. Differentiate with respect to time. 2x into dx by dt plus 2y into dy by dt is equal to 0. This equation we have to keep in mind. In this, we have to solve for dy by dt. That is the final thing. Now we know x. X is already given 4 centimeter. Dx by dt we know. Dy by dt will solve, but y we don't know. Y we will find out from this 4 centimeter equation. How? So x square plus y square is equal to 25. 4 square plus y square is equal to 25. 4 square means 16. So y square is equal to 25 minus 16, which is equal to 9. Therefore, y is equal to root of 9, that is 3 meter. So y value we got now. So therefore, go back to our sum where that differentiation we have done. 2x into dx by dt, equation 1, we are writing back again. From equation 1, 2x dx by dt, 2y dy by dt is equal to 0. So at x is equal to 4, y is equal to 3. We'll solve this now. 2 into 4 dx by dt, they have given you 2 centimeter per this one. So dx by dt value 2. Y value 3 we found out. Dy by dt we will now calculate. 2 into 4, 8. 8 into 2, 16. Okay. So therefore 16 is equal to minus 6 dy by dt, or 16 by 6 with a minus sign. It's called dy by dt. You can cancel 2 here 8 times. Therefore dy by dt is equal to minus 8 by 3 meter per second. So this is negative sign because height is decreasing when the ladder is pulled towards the other end as on the floor. So this is a correct, reasonable answer only. Negative sign, correct. So friends, sums of variations of this kind will be like this. So exercise 6.1, I have done a few sums. Some more sums are there, you can solve them. And with this, I will conclude this. Derivatives, applications of derivatives for variations of area, volume, radius, etc. Next, I will continue with the applications of derivatives for finding out the critical points of a curve, maxima, minima, and then maximizing the profits. Certain sums are there. Those sums will take up in the next video class. Thank you.